Ready?
Yes.
Okay. Another tool we have in our sensory toolkit is the triangle test. This is a type of difference test or discrimination test, sometimes it's called. The purpose of which is to determine whether or not a difference can be detected between two samples. So it's called a triangle test because you have 3 different samples, but you are actually comparing 2 different things. So let's say we're comparing batch A and batch B. You will have 2 samples of one and 1 sample of the other. And the job of the panelist is to decide which one is different, which is the 1 sample compared to the 2 that are the same, and say why. This is done both blind and randomized, so the taster doesn't know, anything about the 3 samples. Yeah, so that's a triangle test. We use this test to know whether or not there is a difference that can be detected between 2 different samples. Most often, this is used when you make a change, so in process or ingredients, it could even be packaging, and you'd like to know if that change had enough of an effect on the resulting beer that a difference can be noticed by a consumer ultimately. There are a few things to be aware of with triangle tests. Number 1 is that you really need to be looking for a statistically significant difference. So you're not only seeing whether or not anyone can detect the difference, we need to make sure that the number of people choosing the different sample is unlikely to be due to chance. So out of 3 samples, the odds are someone's going to pick the right one just by chance. And we need to make sure that that's not the case. So in order to interpret the results of your triangle test, you need to use a table. These are available online, statistical table, that will tell you how many correct answers you need to be above that threshold of chance. So that's the first thing to be aware of. Secondly, the minimum number of tasters for this to be a valid test can be quite high. 20 is often cited as a minimum, could be as much as 40, depending on all of the variables. So it's not a great test to do if you're a small number. Usually it only makes sense for larger groups. You also want to make sure you're only testing 1 variable at a time. So if I'm comparing sample A and B, and they have 3 different things between them, and we detect a difference, it's impossible to say which of those 3 things was the cause. So also with the triangle test, remembering that it will only tell you if a difference is detectable, not what caused the difference, or if the difference is actually significant. So on that point as well, a difference being significant, or whether this difference matters, that's also a drawback of the triangle test in brewing specifically. We expect batch-to-batch variation just from the nature of it being beer. It's a fermented beverage, it has living yeast. We have seasonal variation in our malt and our hops. There's so many variables at play. We expect to have differences. Even the best of the best breweries don't achieve true consistency. So oftentimes, to know whether a difference matters, a change you have made matters, going back to the regular old true to type, true to target test might be a better option, because inherently, that test inherently accounts for a batch-to-batch variation. So maybe we brewed a West Coast and we changed an ingredient. It is more helpful for us to know whether the beer, the batch brewed with that change, still passes our true to target test. And that might be enough for us to know that the still is detected by our panelists as a good batch of West Coast. It's within the parameters and our specifications that we've set.